Hello students, welcome to IMS Academy Gate Score Booster session on communication subject. So this is the first session regarding communication system subject. Today and tomorrow also we are having one more session. In these two sessions we are going to discuss the variety of questions which are very much important for the upcoming GATE exam regarding communication system subject. Okay, so in this particular session I am going to cover the first three chapters related to communication system subject. So those are introduction and amplitude modulation, and then angle modulation, and then AM and FM receivers. Okay, so regarding these three chapters I am going to cover around 20 questions, okay, in this particular session. So this particular session is common for two branches, EC and instrumentation. Okay, so earlier I have done gate score booster sessions regarding two subjects. One is digital circuits and other one is network theory. Okay, digital circuit is common for four branches, EC, electrical, instrumentation, computer science, whereas network theory is common for three branches, EC, electrical and instrumentation. Okay, whoever missed those lectures, whoever missed those sessions either in the live or in the recorded, so kindly watch those sessions whenever you are getting the time from our YouTube channel. Okay, so already the lectures links are already available in our YouTube channel. Okay, yeah, good afternoon Matan. Whoever visiting our YouTube channel very first time, kindly subscribe our YouTube channel and then click on the bell icon so that you will be getting all the instant notifications. And all of you quickly like and share this video link with all of your friends, especially whoever writing the GATE 25 exam or GATE 2026, whoever belong to EC and instrumentation, right? So all those students also can attend this session live, and all those students will be getting maximum benefit from this particular session. Okay. Right. So this is the first question regarding our communication system subject regarding part 1, regarding today's session. Okay. All of you give it a try. Yeah, this is the MSQ question. Either one option or more than one option can be correct. Yeah, good afternoon, Hemant. Yeah, whatever the questions we are covering in this session, okay, for whichever related to that particular question, whatever the formulas involved, so we'll be discussing. But dedicatedly formula session or revision session, that links you can find out from our YouTube channel. Earlier we have done. So you can refer, or otherwise I will put in the comment, like in the comment section also regarding those links. Okay. Yeah, so first of all read the question. So here you are having choose the correct option or options. That means either single option or more than one option can be correct, right? So this question is of MSQ based on the following specifications of double sideband full carrier. So double sideband full carrier or double sideband with carrier, or it is same as standard AM signal amplitude modulation, right? All are one and the same. Double sideband full carrier or double sideband with carrier or amplitude modulation, all are one and the same. So that means this question is related to AM signal. Okay. So regarding the AM signal, they have given maximum voltage is 20 volt, minimum voltage is 4 volt with respect to positive amplitude axis. Okay. Now based on these two information, okay, based on Vmax and Vmin, we have to find out whatever the 4 parameters or 4 options you are having, whether each and every option is correct or not, we have to verify. Okay. So the first option you are having modulation index mu value given 2/3. In the second option you are having peak amplitude of carrier signal, that is nothing but AC equal 12 volts, and options you are having peak amplitude of modulating signal, that means AM, that is 8 volts, whereas option D you are having modulation efficiency, that is eta 18.18%. Okay, we have to verify among these 4 choices which are correct. Okay, so first of all, I hope all of you know the standard formula in order to find out the modulation index when Vmax and Vmin both are given, right? So modulation index mu equal to Vmax minus Vmin divided by Vmax plus Vmin. Vmax minus Vmin divided by Vmax plus Vmin. Substitute the values given. Vmax given as 20, Vmin as 4. 20 minus 4 divided by 20 plus 4. So 20 minus 4 you will be getting 16 divided by 20 plus 4, that is 24. 8 2s are 16, 8 3s are 24. Yes, 2/3 exactly we are getting. So that means option A is correct. As of now we can choose option A. Now we have to verify remaining 3 choices also one by one. So regarding AC, regarding carrier signal amplitude AC, the formula you are getting average of these two. So here AC equal to Vmax plus Vmin divided by 2. So substitute the values given. Vmax is 20, Vmin is 4. Okay, 20 plus 4 divided by 2, that is 24 divided by 2, 12 volts. 24 by 2, that is 12 volts. Yes, exactly satisfying. Option B is also correct. Coming to AM. So here we have done average, right? So here we will be doing Vmax minus Vmin divided by 2. AM equal to Vmax minus Vmin divided by 2. Substitute values. Vmax is 20, Vmin is 4 divided by 2. 20 minus 4, 16 divided by 2. That is 8 volts. 16 by 2, that is 8 volts. Yes, exactly given. See, this is one approach, or you can observe here. So here Vmax plus Vmin by 2. Okay, see whatever the numerator and denominator you are having, okay, in both the expressions divide by 2, whole expression you can divide by 2. Okay, so here Vmax plus Vmin by 2 is nothing but AC, Vmax minus Vmin by 2 is nothing but AM. So that means modulation index is nothing but AM by AC. That is one derived formula. Okay, when you are having envelope of AM signal. So generalized case, this is the formula. From here you are getting modulation index as AM by AC. Okay, so in this way you can find out modulation index, after that AC, after that what you can do, mu equal to AM by AC, since you got AC, okay, and mu value known, so from here also you can find out AM. Okay, just multiply these two, 3 4s are 12, 4 into 2 is nothing but 8. That is another way of solving regarding AM value. Okay, I hope it is clear. Now coming to the modulation efficiency. Modulation efficiency. Here in AM signal, modulation efficiency formula, I hope all of you know, eta equal to mu square divided by 2 plus mu square. Mu square divided by 2 plus mu square. Okay, substitute the mu value here, 2 by 3. 2 by 3 whole square divided by 2 plus 2 by 3 whole square. So just perform square, 2 square is 4 divided by 3 square is 9, 2 plus 4 by 9. You can do simplification further, you will be getting 4 divided by 9 2s are 18 plus 4, that is 22. So here you are getting 4 by 9, here 22 by 9, 9 will get cancelled, and then 2 2s are 4, 2 11s are 22. Okay, so you are getting 2 by 11, you can convert into normal value. All of you give it a try, it is a simple calculation, 2 by 11. All of you find out the normal value, whatever the value you are getting, convert it in terms of or represent in terms of percentage. You will be getting 0.1818. Okay, like that it will continue. So this one you can write it as 18.18% in terms of percentage, because whenever you are supposed to calculate efficiency, in general you will be having in terms of percentage. Okay, but in some questions they are asking in terms of normal value, then you can represent like this. Okay, in this question you are having in terms of percentage, 18.18%. Yes, exactly the same thing we got. So for this question, whatever the 4 choices you are having, all the 4 choices are correct. Okay. Okay, I hope it is clear for everyone. Right. See, whatever the formulas here we are discussing, okay, like these formulas, okay, regarding entire communication system subject. So if you want one quick revision kind of thing, so that session I have done earlier, but regarding that particular link, after today's session over, I will put in the comment section, so that each and every student, whoever want to know regarding the entire communication system subject, whatever the formulas or important points are there, which are going to helpful for the GATE exam, so you people can kindly refer that particular video link. Okay, so that you will be getting each and every terminology. Once whatever the formulas you are having, see how you can, because in the communication system subject you are having lot of formulas. Okay, but if you want to by heart, you can remember for short run, but you may forget like after few days. Okay, that is the reason whatever the formulas are there, if you are practicing, okay, if you are practicing, then while you are solving the question, whatever the formulas are there, if you have utilized, if you have substituted the values and if you have solved, then definitely you are getting familiarity about the formula, that in that manner you can remember the formulas for longer run. Okay. Yeah, Hemant, it's not that case. Okay, see, regarding SSBSC case, in general efficiency means what? Efficiency means your desired output divided by total. Okay, total input. Okay, in the AM signal, desired output is what? Double sideband. Okay, see, whenever you are transmitting any signal with the help of modulation, our desired outcome is message signal. Okay, but in order to transmit the message signal, we are taking the help of carrier signal. So here the total power that is required for transmitting that particular modulated signal, that will come, whereas the numerator, whatever your desired outcome with respect to AM signal or with respect to DSBSC, okay, here desired output is the double sideband power, okay, whereas here the total power that is required for transmitting AM signal. Similarly, with respect to DSBSC, the total power that is required for transmitting DSBSC signal, that will come in the denominator. Similarly, for SSBSC signal, you are transmitting either lower sideband or upper sideband. That means your desired output is any one of the sideband. So that means for one sideband, how much power required, that will come in the numerator, whereas denominator, for transmitting SSBS signal, how much power required. Okay, Okay, I hope it is clear for everyone, right? So whoever not yet enrolled at our IMS Academy for any of the program and whoever writing GATE 25 exam, okay, so whatever the questions we are discussing in our GATE score booster, like that, okay, if you want to get like whatever the knowledge you are having already regarding for your coming GATE exam, but if you want to get good practice and if you want to get the confidence, okay, so I am recommending for all the students to enroll for Test Series Plus program regarding the Google form already provided in the description of this particular video. Okay, so here in our Test Series Plus program, we are providing 130 plus online tests, which includes for every subject chapter level test we are having, and then subject level also we are having basic subject test, advanced subject test, and then we are having multi-subject test as well. Okay, after that we are having all new mock tests as well. Altogether you are having 130 plus online tests. So definitely by practicing these test series, definitely you are getting, you know, like especially how to manage the given time. Okay, in the given time how to maximize your score, and you will come to know in which areas you are strong, in which areas you need to further revise, etc. Okay, and you will come to know in whichever questions or areas wherever you might be doing silly mistake, at least through these tests you are identifying those silly mistakes and you can overcome in the upcoming tests or when you are writing the real GATE exam. Okay, and along with online tests, we are providing GATE previous year question booklet 33 years. Okay, regarding technical subjects you are getting, and regarding maths and general aptitude you are getting with respect to 6 branches like EC, electrical, instrumentation, computer science, mechanical, civil. Okay, and then all these features you are getting. So I am recommending for all the students whoever not enrolled at our IMS Academy and whoever targeting for GATE 25 exam, you people can kindly enroll for Test Series Plus program as soon as possible, because currently the 20% offer is there for limited period. Okay, so kindly fill this Google form so that you can practice good number of questions and you can check your confidence level before you are writing the GATE 25 exam. Okay, and whoever like currently in second year BTech or third year BTech and whoever want to write the GATE exam in the upcoming years like 26 or 27, so for those students I am recommending to enroll for our live online program. So all these are the features regarding live online program. Whoever interested, they can kindly book the free counseling session. Our counselors will discuss in detail about our live online program features. Okay, right, we'll continue further. This is the second question. All of you give it, right? Yes, Nobita, very good. In the DSBSC signal and SSBSC signal, the modulation efficiency is 100%. Very good. 100%, 100 divided by 100 is nothing but 1. Okay, generally efficiency will represent in terms of percentage. There we can say 100%. Yes, just observe this particular question. Here you are having multi-tone. Multi-tone means in the given modulate signal regarding the message signal, you are having more than one frequency. If you are having more than one frequency, that is called multi-tone. If you are having with respect to message signal only one frequency, it is a single tone. Okay, so you are having multi-tone AM signal, S of t equal to, you can just compare this equation with the standard one, like AC into 1 plus mu1 cos 2 pi fm 1t plus mu2 cos 2 pi fm 2t into cos 2 pi fct. Okay, where fc equal 10 power 5 h, the ratio of total power in order to transmit this particular AM signal, right? That one divided by total sideband power. Total sideband power. See, in the previous question what we have done, efficiency is nothing but the total sideband power or double sideband power divided by total power of for transmitting that particular AM signal. That is the efficiency, but here in this question I put volt. Okay, total power for transmitting the signal divided by total sideband power. Okay, so first of all, when you compare this signal with the standard AM signal for multi-tone, from there you will be getting AC equal to 20 volts, AC equal 20 volts, then mu1 equal to 5 by 20, that is nothing but 1 by 4, which is nothing but 0.25. Okay, mu1 cos 2 pi fm 1t plus mu2. Mu2 is 10 by 20, which is nothing but 1 by 2, which is nothing but 0.5. Okay, so when you are having more than one modulation indices, that time in order to find the resultant modulation index. Okay, so generalized formula you are having like mu t square equal to mu1 square plus mu2 square. Like that, if you are having n modulation indices, you can perform like this. You can add. After that, whatever the value you are getting, that entire value is nothing but resultant modulation index square. Okay, if you want only modulation index, total modulation index, you can perform root. Okay, but for the timing I am keeping like this. So here mu1 value you can substitute here and then mu2 value. So you are getting 0.25 whole square plus 0.5 whole square. Do the simplification. From there you will be getting 0.3125. Okay, now according to the question, just let us represent the ratio of those two parameters. Okay, so here the ratio of total power for transmitting AM signal for multi-tone. Okay, so that is PC into 1 plus mu t square divided by 2. See, for generalized case, when you are having only one modulation index, then you are having PC into 1 plus mu square by 2. When you are having more than one modulation index, okay, for generalized case you can keep in place of mu t. Okay, right. Then this is the numerator term. Denominator term is what? Total sideband power. Okay. So just observe here. When you multiply PC with both, okay, the first term you are getting what? PC, that is the carrier power. Okay. Next term what you are getting? PC into mu t square by 2, that is nothing but total sideband power. Okay, that is the reason why we are calling this the AM signal or double sideband with carrier or double sideband full carrier, because you are having both the sidebands and along with that you are having the carrier also. Okay, so now regarding the denominator part, only this second one, that means PC mu t square divided by 2. Okay, so here PC is getting cancelled. Okay, numerator you can do the simplification. So you will be getting 2 plus mu t square divided by 2, you will be getting, here also divided by 2, both will get cancelled. Here you are having mu t square. Okay, now you can substitute. So why I not calculate mu t? Because in this formula you are getting mu t square. That is the reason. Okay. See, just you can observe earlier, regarding the modulation efficiency, for single tone modulation we have kept mu square by 2 plus mu square. Okay, but in this question I asked volta, so that means 2 plus mu square divided by mu square. Like that also you can get. Okay, but just for understanding I have discussed from this particular statement accordingly I have represented. Okay, Hemant, I hope it is clear now, right? Okay, now you can substitute mu t square value here. So 2 plus 0.3125 divided by 0.3125. So you are getting 2.3125 divided by 0.3125. All of you do the simplification of this one. You will be getting 7.4. 7.4. Okay, I hope it is clear for everyone. Next question. This question is of MSQ. Either one option or more than one option can be correct. Okay, so in this question you are having the carrier signal C of t equal to AC cos 2 pi f ct format and message signal M of t equal to AM cos 2 pi f mt format. Okay, are used to generate DSBSC signal, that means double sideband suppressed carrier. Okay, right. Then choose the correct option or options. This question is of MSQ. Okay, so two choices you are having regarding the bandwidth of DSBSC signal you are having, and two choices you are having total power required for transmitting that DSBSC signal. So after reading the choices here for this question, among these two choices at most one option can be correct. Among these two choices at most one option can be correct. Now all of you give a try. I have given the hint what they have given and what you are supposed to calculate. Okay, now I will be given time. All of you give a try. Yes, very good, Navita. So you are from which branch? You can mention whether you are from EC or instrumentation, and you can mention like currently in which year BTech. Yes, very good, Navita, very good. So here regarding AM signal and regarding double sideband suppressed carrier, the bandwidth formula remains same. Okay, as the name implies here, double sideband. Okay, upper sideband you are having, lower sideband you are having. Difference of those two frequencies is nothing but bandwidth. Okay, so here coming to the bandwidth, 2 FM, and here regarding message signal, whatever you are having, you represent in the 2 pi f format. Okay, so when you represent 2 pi f format, 2 pi into 4 into 10 power 3, right? 4 into 10 power 3, so 2 4s are 8 into 10 power 3 is nothing but kilo. So you are getting 8 kilohertz, right? So that means here option B is correct. Option B is correct. Yes, very good, Navita. Right, 8 kilohertz. Okay, now total power required for transmitting DSBSC signal. It is very simple. See, DSBSC signal in the simplest format, or I can say regarding the standard equation of DSBSC signal in simplest form, you are having the product of message signal and carrier signal. The product of carrier signal and message signal, or message signal and carrier signal, vice versa. Okay, in any order you can consider. In the time domain equation, you are having product of two signals. Okay, right. Now, if you want to calculate the power of resultant DS based signal, it is very simple. It is very simple. Just you have to calculate individual powers and then you can multiply. That's all. Okay. Power of DS based signal is equal to power of carrier signal, you can multiply with power of message signal. Carrier power multiply with message signal power, that's all. Okay. So here carrier signal power, you are having 20 cos 2 pi f ct. Whenever you are having cos function or sine function, the power formula or average power, all are one and the same, is nothing but the peak value square divided by 2, right? So that means here 20 whole square divided by 2, right? Then message signal power, here 5 square divided by 2. Okay, I hope it is clear for everyone, right? Then 20 square is nothing but 400 into 5 square is 25 divided by 2 2s are 4. Here 400 times 100 into 25, that is 2500 watts. 2500 watts. Okay, so that is there in option D. For this question, two choices are correct, option B and option D. Next one. So in this question, you are having the block diagram like this. Okay, just observe here. You are having product modulator. Product modulator is nothing but what? Multiplier. Okay, in general words, it is a multiplier. Right. So here you are having S of t signal, and then here you are having carrier signal. And regarding S of t, you are having the expression like this: 10 cos 2 pi f ct into m of t. Okay, and here you are having 10 cos 2 pi f ct. You can multiply. Okay. That output equation, whatever you are getting, that output we are passing through low pass filter, which is having the cutoff frequency FM. Now you are getting final output. Now what is the question is, here regarding the message signal m of t, power they have given 50 watt, and whatever the output here you are getting, regarding that particular signal, you have to find out the power. That's all. That is the question. Here in this question, whatever the power you are getting, you have to represent in the order of kilowatts. All of you give it a try. So here if you observe this particular block diagram, so what you are getting, any clue or idea? Whatever the block diagram they have given, that particular block diagram represents what? Here you are having product modulator or multiplier. Here you are having modulated signal as one input and the locally generated carrier signal you are having, and after that you are having low pass filter. So when you see this particular configuration, that is nothing but what? Yes, very good Nobita, very good. It is a synchronous detector. It is a synchronous detector, right? So that means this particular block diagram is nothing but demodulation of DS based signal, that's all. Because here the incoming modulated signal is nothing but message signal and carrier signal product. That means DS based signal, and here we are having carrier signal. So here the purpose of this particular block diagram, in order to demodulate DS based signal, and from there we are able to get the message signal. Yes, very good Ashni, very good Ashni. It is a synchronous detector. Okay, right. Fine. Now, as per the block diagram, you can proceed step by step. That's all. Okay. So first of all, output of product modulator. For the time being, I will label as V suffix P. Okay, product modulator. Accordingly, I am putting suffix as P just for reference. So here Vp equal to, you have to multiply these two signals. Okay. 10 cos 2 pi fct into m of t, that is your s of t signal, and then you have to multiply the carrier signal 10 cos 2 pi fct. Now here 10 into 10, 100, then cos term, cos A, you can write it as cos square A, and then you are having m of t. So cos square A, we can write it as 1 plus cos 2a by 2. Plus cos 2a by 2. So that means you are getting 2 into 2 pi fct. Whole term you have to multiply with m of t. Okay, here 250 times. Now you can multiply 50 and m of t with both the terms. Okay. So from here you will be getting 50 m of t plus 50 m of t cos, I am representing in the 2 pi f format. So 2 pi into 2fc into t, cos 2 pi into 2fc into t. Okay. Now here you are having two terms. Okay, regarding this output of product modulator, you are having two terms. Now when you observe the first term, here you are having only message signal. Definitely that message signal maximum frequency you are having FM. Okay, whereas here message signal you are having that one you are multiplying with one carrier signal which is having the frequency 2fc. Okay, so when you are having message signal and carrier signal product, from there you are getting fc plus fm or fc minus fm. Okay, but now here you are having fm, here 2fc. From here you are going to get, regarding this particular signal, you are going to get 2fc plus or minus fm. Yes sir, 2fc plus fm, that is the upper sideband, or you can say maximum frequency 2fc minus fm, that is the minimum frequency. Now here you are using low pass filter, definitely it will allow low frequency signal. So this frequency is what? Higher than fm, right? Definitely this particular term won't allow by the low pass filter, only this first term is going to be passed by the low pass filter. Yes or no? So output of low pass filter you are getting 50 into m of t. Suppose in the same question, instead of low pass filter, if they have given band pass filter and center frequency if they have given like 2fc, okay, and upper I can say upper cutoff frequency is 2fc plus fm, lower cutoff frequency is 2fc minus fm. In that case, among these two terms, the second term will be passed by the band pass filter. Like that, in the given question, when you are having the block diagram, just for every stage you can find out the expression, and after that, based on the given filter, you can decide whether which particular term is allowed by the corresponding filter. Okay. So as of now we are getting output of low pass filter, that is 50 into m of t. Now for this particular signal they are asking the power, that's all. They are asking the power. Okay, just for easy understanding, like earlier, here double sideband suppressed carrier is nothing but what? Message signal and carrier signal, the product, right? So in order to find out the resultant signal power, individual signal powers we have multiplied, correct? In a similar way, whenever you are getting like this, okay, here also just observe 50 into m of t. Okay, m of t is one signal and 50 is, let us consider that is also one signal. Okay, say for example, if you are having DC signal like 50 volts, what is the power of it? DC voltage you are having 50 volt, what is the power of it? 50 square, correct? Like that you can treat. Here 50 volt you can consider as carrier signal, or you can consider that is a DC signal. You can find out the power of this one, you can find the power of this one, after that you can multiply, that's all. Okay, so here you are getting regarding the power of, because they are asking power of the output signal, correct? Power of V naught, that is 50 square into power of message signal. Power of message signal already they have given. You are having 50 watt, 50 square, that is 2500 into 50. So here total you are getting 3 zeros, we can write it as kilo, then 5 into 25, that is nothing but 125. So since in this question I have asked that whatever the resultant power you are getting, you have to represent in the order of kilowatts. So answer for this question is 125. See, similar kind of question, whenever you are getting NIT questions in the GATE exam, especially for that particular parameter, if you are getting the units, okay, in which order of units they are asking, that is also most important. See, in this question, since I asked in the order of kilowatt, answer is 125. For the same question, if they ask in the order of watts, then the answer will be 125,000, okay, or 12,000, 125,000, correct? Yeah. So in that manner you have to mention. Suppose if they ask in the order of watts, but that time if you are mentioning 125 for the same question, that is not correct. Okay, of course there won't be any negative marking, but the marks you are losing, correct? You are supposed to get marks for this question, but because you haven't take care about the order of units, because of that you might be losing the marks. Okay, right, that is the reason for NIT question, always after solving the question once again recheck whether like order of units, in which order they have specified, accordingly whether my answer is correct or not, you can cross check. Okay, right, next question, all of you give a try. So in this question you are having the modulation index 0.6, the ratio of SSB-SC signal power to the AM signal power. Ratio of SSB-SC signal power and AM signal power, that you have to calculate. see, it is very simple. So here you have to find out the ratio of SSBSC signal. That means you are passing only one sideband, single sideband, right? Okay. So that power divided by AM signal power. Power of single sideband suppressed carrier divided by power of AM signal. Okay, just for reference, first I am representing power of AM signal. Okay, from there we'll represent power of SSBS signal. So power of AM signal we have discussed already in one of the earlier questions. So you are getting PC into 1 plus mu square by 2. Yes or no? PC into 1 plus mu square by 2. Yeah, Akanksha, you can cross check once. Yeah, so PC into 1 plus mu square by 2. So here when you multiply PC with both, okay, so you are getting PC is the first term, second term you are getting PC mu square by 2. Yes, very good Nobita, very good. Okay, the first term is carrier power, second term is double sideband power. Okay, double sideband power or total sideband power, that is PC mu square by 2. But here we are telling what? Single sideband. That means here double sideband power is PC mu square by 2. Single sideband means half of that. So that means PC mu square by 4. Okay, I hope it is all of you are getting the clarity. Okay, now here PC is getting cancelled. Okay, you can do the LCM here. So mu square divided by 4 divided by 2 plus mu square whole divided by 2. So from here to here 2 times. Okay. So now you are getting mu square divided by 2 into 2 plus mu square. Okay, right. Now you can substitute the mu value. That's all. Yes, very good Ashni, very good. Yeah, mu value you can substitute 0.6 whole square divided by 2 into 2 plus 0.6 whole square. So 0.6 whole square, that is 0.36 divided by 2 into 2 plus 0.36. So directly I am writing 2.36. Okay, you can do the simplification of this one. Yes, very good Akanksha. 0.076, very good. Okay, you can do the simplification. You will be getting 0.076. So in this question I asked up to 3 decimal places. Okay, see in the GATE exam also for NIT questions, whenever you are getting integer, definitely we will mention, but whenever you are getting real number or fractional number, so fractional part, so they will specify. We have to consider after the decimal point how many values we have to consider. If they don't specify, you can consider up to 3 decimal places. Okay, but suppose after solving some question, if you got like 0.25, so that number you can enter. But whenever they are clearly mentioning up to how many decimal places you have to consider, accordingly you can round off. Okay. So for this question 0.076. This is the correct answer. Okay, right. Yeah, next one very interesting question. All of you give it, right? Okay, first I am giving the brief introduction, like idea what they have given and what you are supposed to calculate. Okay, so here you are having one block diagram like this. Here you are having SSBSC modulator, that means output you are getting SSBS signal. Here you are having message signal and then carrier signal. With the help of these two you are getting SSBSC signal. Okay, so in this question you can treat like single tone only. Suppose if it is a multi-tone, definitely they will specify in the question. Okay, so for the time you can consider like single tone only. Okay, single tone SSBSC signal, right? Now that SSBS signal whatever you are getting, that signal and here once again carrier signal. Those two we are passing through one summing circuit. It will perform addition of those two. That addition of those two, what are the expression you are getting, that one we are giving as input for envelope detector. Now at the envelope detector output, that output they have represented as S of t. Okay. Now in this question, you are having the data regarding SSBSC signal. Regarding SSBSC signal, output whatever you are getting, regarding that output, normalized power given as 0.5 watt. Normalized power given as 0.5 watt. Now you have to choose the correct option. This question is MCQ only. Okay, choose the correct option regarding S of t. So what are the final expression you are getting? Regarding that, among these four choices, which one is correct? Okay, this is a very interesting question. I am giving 2 minutes time. All of you give a try. This is a very good question. You can mention it is an excellent question. See, just now only we have discussed regarding DSBSC signal. Regarding DSBSC signal, you are getting like this: message signal and carrier signal product. Okay, if you are doing a simplification, you will be getting like in one term FC plus FM, in another term you are having FC minus FM, right? So among those two, any one term we are passing. That's all. That is your SSBS signal. That is your SSBS signal. Yes, very good, Akanksha. Very good, excellent, excellent. So here, like for generalized case, you can represent output of SSBS signal, output of SSBS signal, output of SSBSC modulator. So you will be getting either upper sideband or lower sideband, right? So cos of omega c plus omega m you will be getting, or cos of omega c minus omega m, okay, into T. Any one sideband you will be getting, either upper sideband or lower sideband, and here you will be having some amplitude. Okay, for the time being I am representing as A. Okay, right. Now in this question they have mentioned regarding output of SSBSC modulator having normalized power as 0.5. Okay, so when you are having either cos or sine signal like this, so regarding the power you are having peak value square divided by 2. So in this question it is given as 0.5 watt. Okay, so from here you can do simplification. A square you are getting 2 into 0.5, that is 1. That means A value is 1, that's all. So here in this question the amplitude of that particular either upper sideband or lower sideband you are having 1, that's all. Okay, so from here you are getting this equation, you are getting cos of omega c plus or minus, generalized case I am mentioning. Okay, now that is the signal you got here. Next, here you are having carrier signal. Those two you have to sum together and then you have to give as input for enveloped detector. Output of summing circuit is equal to cos okay, I will be writing this one later. For the timing I am expanding this equation. So cos A plus B, if you are having cos A cos B minus sin A sin B, if you are having cos A minus B, cos A cos B plus sin A sin B. Okay. So this one I am writing cos A plus B equal to cos A cos B minus sin A sin B. If you are having plus sign, here minus, or if you are having minus, here plus. Okay, right. So this is the equation you got. Now you can write output of summing circuit. Output of summing circuit, you are getting this expression, you have to add with carrier signal AC cos omega ct. So directly I am writing, so here you are getting AC cos omega ct plus this entire term. So that means I am taking cos omega ct as common. Then AC you are having, okay, then here you are having cos omega mt. Okay, I hope all of you are getting clarity. AC cos omega ct plus this term, from both I took cos omega ct common, then you are having from the first AC and from here you are having cos omega mt. After that here you are having minus plus sin omega ct into sin, sorry, here it is sin omega mt, sorry. Cos A cos B minus sin A sin B. Okay. So here you are having sin omega mt into sin omega ct. Okay. Now all of you just observe this equation in the standard format, like say for example x cos omega ct plus y sin omega ct, or x cos omega ct minus y sin omega ct, whenever you are having like this. Okay, so that expression if you are passing through envelope detector output, you will be getting square root of x square plus y square. Okay, square root of x square plus y square. Once if you know that relation, then you can easily solve this question. Okay. Okay, I will be writing in the next slide. Output of envelope detector is equal to, okay, just for reference here I am mentioning this is like x and this term is like y. X cos omega ct minus or plus y sin omega ct. For this you are getting square root of x square plus y square, where x is nothing but first term, y is nothing but second term. Okay, ac plus cos omega mt whole square plus sin omega mt. Sin omega mt whole square, that is nothing but sin square omega mt. Both are same. Okay, now you can expand further. AC square plus cos square omega mt plus 2AC cos omega mt. 2AC cos omega mt. It is simple. A plus b whole square, a square plus b square plus 2ab. Now you can write this term as it is. Okay. Now here cos square plus sin square is nothing but 1. Okay. So you are getting 1 plus AC square 1 plus AC square plus 2AC cos omega mt. Under root. Okay, now you can cross check. Yes, square root of 1 plus AC square plus 2AC cos omega mt. 2AC cos omega mt. That means option D is the correct answer. See, generally here few students may do silly mistake, like whenever you are having cos x cos omega ct plus y sin omega ct. Okay, see, if you are having these two are different frequency, that time you can use superposition theorem. If you are using superposition theorem, then accordingly you will be getting resultant output voltage. You can get either x plus y or x minus y. That is fine, because when you are considering this signal, other signal you are deactivating, or when you are considering this signal, other signal you are deactivating, because those two signals are having different frequency. But here also the same logic few students may apply, but actually if you observe, these two are having the same frequency. Whenever you are having two like sine signals or cos signals like this, or one is sine, one is cos like this, okay, because ultimately here internal frequency term when you observe, if both are having same, that means here you cannot apply superposition theorem. Rather you should do the simplification of this one. Okay, when you are having the expression like this, after doing the simplification you will be getting one expression like square root of x square plus y square into, here you are getting like sin a cos b plus cos a sin b is nothing but sin a plus b, or cos a cos b plus sin a sin b is nothing but cos a minus b. Like that format, either sin or cos you are getting, but the amplitude wise you are getting square root of x square plus y square. Here by looking wise it is looking like two different signals, but if you do simplification you are getting only one signal. Okay, I hope all of you got the clarity. This is very, very important, not only in this subject, even in other subjects as well. Okay, whenever you are having regarding cos and sin, if you are having the frequency is same, that time you should not apply superposition theorem, because both are having the same frequency. When we can apply superposition theorem? Whenever the sources are having different frequencies. Okay, right. So this is the output of the envelope detector you are getting. After that you can substitute. From there we are getting option D for this question. I hope it is clear for everyone. If you are having any doubt, you can mention in the chart. Yeah, up to previous question, that means first 6 questions we have discussed regarding the first chapter, that is introduction and amplitude modulation. Now we are discussing the questions regarding second chapter, that is angle modulation. All of you give it a try. This is the MSQ question. Yeah, good evening, Gopal. Excellent, Nobita. Excellent. Here in this question, regarding the modulation index, beta of wideband FM. With respect to wideband FM, regarding the modulation index, you have to find out, or you have to identify the correct options. Yes, very good, Akanksha. Excellent. Yeah, Ashwini, you can cross check once. Regarding wideband FM, the modulation index formula is what? Beta equal to delta F by FM. Beta equal to delta F by FM, where delta F equal to KF into AM. Delta F equal to KF into AM. Now just observe this particular relation, that's all. Here AM is there in the numerator, that means if you are varying AM, okay, according to the modulation index is varying linearly, correct? Yes, linearly, right? So now you can observe it is proportional to the peak amplitude of modulating signal. Yes, option A is correct. Option A is correct because these two are in the numerator. Okay. Now, since you are having FM in the denominator, so here in this case it is inversely proportional. It is inversely proportional. So it is inversely proportional to the frequency of the modulating signal, option D. See, among A and B, when you observe, here it is proportional to peak amplitude, okay, and option C, option A, option C you can observe, here directly proportional, here inversely. That means since A is matching, option C won't be correct. Okay. Now among B and D, with respect to frequency, since it is satisfying for inversely proportional, obviously directly proportional it won't satisfy. So that means for this question, two choices are correct, A and D. Okay, next question, all of you give it a try. In this question, you are having the modulation index of FM 0.4. Modulation index is 0.4, and the message signal frequency you are having 5 kHz, and you have to find out bandwidth of FM signal. Bandwidth of FM signal. Yeah. For this question, like sometimes few students may do silly mistake. Okay. Yeah. Currently also, like the students like still they are doing the silly mistake. Okay. No issue at all. Yeah. Nobita and Akanksha, actually you have used the earlier formula. Okay. Whatever the formula, sorry, whatever the formula you have used regarding the bandwidth, that formula you can apply when the FM signal is wideband, right? But here in this question they not mentioned whether it is wideband or narrowband, but you are getting the clue based on the modulation index value. Based on the modulation index value. Yes, very good, very good. Yeah, so in this question you are having modulation index value as 0.4. Since you are having modulation index value as 0.4, this value is less than 1. Okay, so that means it is narrowband FM. So whenever you are having narrowband FM signal, right? So bandwidth of narrowband FM signal is same as AM signal. AM signal. Yes, very good, Akansha, very good. Yeah, if you are getting beta value less than 1 or far less than 1, that is narrowband FM. Okay, when you are getting narrowband FM signal bandwidth is same as AM signal bandwidth. So in this case, bandwidth of narrowband FM signal is equal to 2 times FM. 2 times FM, that's all. So here in this question, FM value given as 5 kHz. So 2 into 5k, that is nothing but 10 kHz. 10 kHz. So 10 is the final answer, because here you are having order of units are kHz, right? So answer for this question is 10. Okay, no issue. Okay, whatever the silly mistake you've done, no issue. But at least the main agenda of this session is, in general, even though students know each and every formula and each and every concept, okay, but still in some questions or some regarding the concepts, they may do silly mistake. So this is the session that is going to help all the students. Wherever you people may be doing a silly mistake, at least you can do now, no problem. But at least since you have done the silly mistake now, definitely the silly mistake you won't repeat in your GATE exam. Okay, that is the main motto. Okay, and wherever possibility is there, we are discussing all the interesting questions, and even like how to solve the given question in the shortcut also, those varieties also will be covering. And not the least, wherever in general students can do silly mistake, you are getting, okay, all those areas, you are getting the alert, so that definitely you can overcome in your GATE exam. Yeah, Nobika, actually we are defining with respect to wideband FM and narrowband FM based on the beta value. If you are getting beta value less than 1, you can consider it as a narrowband FM. Generalized case we will be telling beta value far less than 1, but you can consider beta value less than 1 also, it is narrowband FM. If you are getting beta value greater than 1, it is a wideband FM. Yeah, say for example, when you consider 2 into beta plus 1 into FM, okay, yeah, for that case you can consider with respect to wideband in that case. Yeah, next question, all of you give it, right? You are having the carrier signal and you are having the message signal. Now in this question they have given one important relation. Based on that you have to find out the bandwidth of FM signal. All of you give it, right? Yeah, Nobita, it is very simple regarding your question, whatever you have asked. Like say for example, when you're having wideband FM formula, 2 into beta plus 1 into FM, right? So there, if you are considering in that expression, I mean to say, if beta value is less than 1, okay, so that means 1 plus beta, you can approximate to 1 only. That time you are getting what? 2 FM, that is nothing but narrowband FM. But when you are getting beta value 1, so in that formula when you are keeping, what you are getting? 2 into 1 plus 1 into FM, that means 4 FM. But if you are using narrowband FM, you are getting 2 FM. That means that is the reason you can consider wideband FM, even in the like exactly at edge or border, you can say. Because whatever the generalized formula you are getting, like when you are considering beta value less than 1, that time only we have done the approximation. So from the wideband FM, when you are doing the approximation, from there you are getting narrowband FM formula regarding bandwidth. I hope it is clear, Nobita. Yes, very good, Akansha, very good. Yeah, just observe this question. Here you are having carrier signal C of t equal to 2 cos 2 pi f ct format. Okay, then message signal m of t equal to am cos 2 pi f mt format. But here 2 is not there. When you represent 2 pi f format, you can multiply and divide with 2. Okay, then if the maximum frequency deviation of FM signal is 4 times the bandwidth of DS based signal. Okay, so first consider this data. Delta F max is equal to 4 times bandwidth of DSBSC, right? Yeah, very good, very good. Bandwidth of DSBSC. DSBS signal or AM signal, bandwidth is what? 2 times FM. 2 times FM. Okay, from here you are getting 4 2s are 8 into FM. So from here you can get the modulation index beta equal to delta F max divided by FM. Delta F in short you can consider, or delta F max, your wish. Okay, divided by FM. FM means it is the maximum frequency of message signal only, correct? Okay, so that means from here you are getting 8 only. When you bring FM to the left hand side, you are getting 8. Yes, very good, Ashni. Yeah, but here you can take care about the units. Okay, whatever the value you got with respect to kilohertz, that is correct, but here you are having hertz. Okay, right. So beta value we got 8. So beta value 8, that is greater than 1. So that indicates what? Wideband FM. Wideband FM. So whenever you are getting wideband FM, so the bandwidth formula is 2 into beta plus 1 into FM. Yeah. So bandwidth of wideband FM 2 into beta plus 1 into FM. Beta value just now we got 8. FM value, here in this question, see most of the people may do silly mistake here. They may consider FM value as 1000 Hz or 1 kHz, but here you don't have 2, right? So that's why here we have to multiply and divide with 2. So when you are dividing with 2, you are getting like 10 power 3 divided by 2. I hope all of you got the clarity. Okay, since I have mentioned here the hint point, that is the reason no single student have done silly mistake here. But in the GATE exam, when you are getting like this expression, majority of the students may feel like this, 2 pi f format only already given, but here 2 is missing, multiply and divide with 2. Okay, right. So here 2 is getting cancelled, 8 plus 1 is 9 into 10 power 3, we can write as 1000. See, in this question, since you are having the units in the order of H, 9000 is the answer. But in the same question, if they mention in the order of kilohertz, then answer will be 9. So accordingly, you can take care. For NIT question, there is no native marking, but whatever the marks assigned for NIT, if you want to get, you should take care about the order of units. Okay. So for this question, answer is 9000. Yes, Akanksha, I will be covering in today's session and tomorrow's session regarding communication system subject, all the important topics, okay, related questions I am covering. Okay, in today's session I am focusing with respect to first 3 chapters. Okay. Okay, after attending today's session, tomorrow's session, suppose if you people want some more extra practice questions, okay, that links also, as I mentioned earlier, in one of the year I have done quick revision session. That link I will be sharing in today's session after the session is getting over. In the comment section I will be putting. Similarly, after the tomorrow session over, at the end of after completion of live session on tomorrow, there in the comment section I will be putting one more link regarding gate score booster, which I have done regarding communication system subject in one of the earlier year. Okay, so that link also I will be putting. Whoever like having more time and whoever want to do some more practice, you people can do it. Okay. But definitely whatever the questions I am covering in today's session, tomorrow's session, definitely I am covering each and every important topic related to communication system subject with respect to your coming GATE exam. Okay. Just like earlier I have done for digital 2 sessions, similarly network theory 2 sessions, right? In a similar manner, I am going to cover good number of questions. In today's session, I am covering 20 questions regarding first 3 chapters. Similarly, tomorrow also I will be doing around 20 questions. Okay. Yeah, Akanksha, you are from 3rd year or final year, BTech? I think you are from EC, right? Yeah, all of you give a try this question. Yeah, regarding receivers also I will be covering today only. That is the 3rd chapter regarding communication. So all the questions we are discussing in the chapter flow. Okay. First 3 chapters I am focusing today, and remaining 4 chapters I will be focusing on tomorrow. Yeah, final year, very good. Yeah, this is the MSQ question. Yes, this is the MSQ question. In which of the following modulation techniques? Okay, this question is MSQ. Yes, very good, Navita, very good. 2 options are correct, both C and D. See, just now only we have discussed regarding bandwidth of wideband FM. Bandwidth of wideband FM, we got 2 into beta plus 1 into FM. Right. See, whatever the formula we are using regarding wideband FM, the same formula we can use with respect to phase modulated signal. With respect to phase modulated signal, the formula wise it is remains same. 2 into beta plus 1 into FM. But what is the difference here regarding beta value? See, here beta is nothing but delta F by FM, which we already discussed. Whenever the question is FM signal, if they have given already beta value, you can substitute here. Okay, but if they're not given beta value, based on these two data, you are calculating beta value. Okay, coming to the phase model signal. Beta is nothing but delta phi max. Okay, delta phi max. That means phase deviation maximum value is nothing but modulation index. Okay, so either with respect to frequency modulation you are calculating based on this, with respect to phase modulation you are calculating based on this. Okay, whenever they have already given the beta value and FM value they have given, directly you can use same formula only with respect to FM, wideband FM, and with respect to phase modulation, phase modulated signal. Now read the question. In which of the following modulation techniques the bandwidth of modulated wave will be increased by increasing bandwidth of modulated wave will be increased by increasing the value of modulation index. Now in these two cases, if you are increasing the modulation index, accordingly bandwidth is going to increase, right? So that means option C, option D. Coming to AM and narrowband FM, we already discussed earlier. Regarding AM, bandwidth is 2 FM. Regarding narrowband FM also 2 FM. There it is independent of modulation index. Okay. Right. So in some questions, just I am giving one hint. Of course, I already covered that point earlier also. See, whenever in the question if they are not given beta value, okay. So from the given data delta F and FM, we are calculating the beta value. After that, based on the beta value, we are deciding whether we have to use 2 into beta plus 1 into FM or just simply 2 into FM. Okay, based on the beta value, we are identifying whether it is narrowband FM or wideband FM. If it is narrowband FM, 2 times FM. If it is wideband FM, 2 into beta plus 1 into FM. Okay, I hope all of you got the clarity. Right. Next question, all of you give a try. Yes, very good Ashni, very good Akansha. Ashni, how much you got beta value? Yes, very good Akansha, very good. Nobita, you are almost closer to the answer. See, in this question, they have given Fi max and Fi min. Okay, I hope all of you know Fi max. Okay, just for reference, I am mentioning Fc plus delta F max, or you can say delta F, your wish. Okay, Fc plus delta F max, whereas Fi min is equal to Fc minus delta F max. Okay, right. So here they have given Fi max as 1080 kHz, right. Fi min 920 kHz, 920 kHz. Okay. Now, if you subtract second one from first, okay, if you subtract second one from first, so here in this case Fc will get cancelled, then plus delta F max plus delta F max, that means you are getting 2 times delta F max is equal to, here you will be getting 160 kHz, 160 kHz. This is 2 times delta F max. Okay. From here you will be getting delta F max equal to 160 divided by 2, that is 80. So here you are getting 80 kHz. All of you cross check up to this step whether you are able to get correct or not. Ashni and Nobita, you can cross check. Up to here if you get correct, definitely you will be getting final answer correct. Okay, somewhere you might have done silly mistake here only, just cross check. Okay, delta F max we got 80 kHz. Now in this question they have given message signal, bandwidth of modulating signal. Yeah, okay, some students might have done silly mistake here in order to consider this one. See, whenever all of you just confirm, if you are able to mention here correct, that means okay, you will be getting correct answer only, but whoever might have considered wrong assumption here, okay, because of that if you are getting wrong answer, at least I want to get to know where you done the silly mistake. Now all of you just confirm me, bandwidth of modulating signal, here they have given 10 kHz, is it whatever 10 kHz they have given, whether it is FM or whether it is 2FM? Ashni and Nobita, you can answer in the chart whether 10 kHz is nothing but FM or whether 10 kHz is nothing but 2FM. Yes, very good Nobita, very good. See, whenever you are having the message signal or modulating signal or baseband signal, okay, so baseband signal you are having that particular signal is centered around 0. See, in general while you are representing the spectrum, we are considering along with positive frequency axis, negative frequency axis, but in practical whether frequency value can we represent negative like minus 50 Hz or minus 20 Hz, is it possible? Practically no, but theoretically while drawing the spectrum for symmetrical point of view we are using the negative frequency spectrum. But whenever the context bandwidth means with respect to positive frequency axis, the given signal from which frequency to which frequency it exists, the range of frequency, or I can say difference of the maximum frequency and minimum frequency on the positive frequency axis, that is nothing but bandwidth. Okay, whenever you are having the baseband signal or modulating signal or low frequency signal, bandwidth means FM only. But why we are drawing the spectrum, even though like practically we cannot represent negative frequency, but why we are drawing the spectrum on negative frequency axis, the reason is only one thing. After you are performing the modulation like AM signal, AM modulation or DSBSC, the entire spectrum you are shifting around FC. FC is what? High frequency signal. That time you are getting like upper, or I can say maximum frequency you are getting FC plus FM, minimum frequency you are getting FC minus FM, and the center frequency you are getting FC. Now the entire graph or spectrum shifted towards positive frequency axis. Now for that particular signal bandwidth is 2FM. See, initially with respect to modulating signal, if you don't draw the on the negative frequency axis spectrum, only if you consider 0 to FM, then after the modulation you are losing the information with respect to Fc minus Fm to Fc. That is the reason we are drawing the spectrum regarding the modulating signal or baseband signal on the negative frequency axis also. Okay, now I hope all of you got the clarity, Nobita and Ashni. Whenever you are having the baseband signal or modulating signal, even though bandwidth, terminology mentioned that bandwidth is nothing but maximum frequency of that given signal, that's all. Okay, don't get any confusion. Okay, or in other words, very simple, on the positive frequency axis, the maximum frequency of the signal minus minimum frequency of the given signal, that's all. Fm minus 0 is nothing but Fm hertz only, that itself is the bandwidth. Okay, with respect to modulating signal, with respect to AM signal or DSBSC to FM, with respect to SSBS signal, FM only. Now you can correlate. With respect to SSBS signal. Either we are passing lower sideband or upper sideband. When you consider any one sideband, bandwidth is FM. Now that one will match with respect to your message signal. That's all. Okay, right. Now, FM you are having. Okay, this 10 kilohertz is nothing but FM. Okay. Now you are having delta F and then you are having FM. Now take the ratio. From there you are getting beta value. Beta equal to delta F max, that is 80 kilohertz divided by here FM 10k. So that means you are getting 8. This value is greater than 1. So which indicates wideband FM. Okay. So regarding wideband FM, the formula remains same, 2 into beta plus 1 into FM. 2 into beta value is 8 plus 1 into FM is 10k. Okay, 8 plus 1 is 9, 9 2s are 18, 18 into 10, that is 180 kilohertz. Yeah, no issue at all for any question. Okay, even if you are doing silly mistake, as I told earlier, with the help of these sessions, you are getting to know each and every concept, each and every terminology, each and every formula. You are getting the clarity. Once if you are getting the clarity, definitely you can overcome whatever the silly mistakes you might be doing still currently in this session or tomorrow session. Definitely you can overcome these kind of silly mistakes in your actual GATE exam. Okay, right. Yeah, next question all of you give it, right? Yes, very good, Nobita. You can cross check. This question is MSQ. Either one option or more than one option can be correct. This question is MSQ. So first read the question once. Here you are having regarding FM, audio frequency they have given. That means what are the information they have given with respect to message signal only. Okay. Yes, very good, Nobita, very good. So here you are having audio frequency. That means regarding message signal only. So that value, frequency value correspond to message signal, that is 500 Hz. FM equal to 500 Hz. Okay. Then the corresponding voltage they have given 2.4 volts. That means you can consider AM equal to 2.4 volts. Okay. Now frequency deviation given as 4.8 kilohertz. Frequency deviation, that is delta F. Delta F you can consider, or maximum frequency deviation. Both are same only. In some question they will specify maximum frequency deviation. In some question, in simple words they mention delta F. Okay. Both are one and the same. Okay. While solving the questions you can consider maximum only. Maximum frequency deviation. So that is 4.8 kilohertz. 4.8 kilohertz. Okay. Right. Now, okay, up to here you are having like this. Now, delta F equal to, delta F or delta F max, both are same. Delta F equal to Kf into Am. Kf into Am. So here delta F we are having 4.8K. Okay, is equal to Kf. We don't know, we have to calculate, and then Am value is 2.4. So here 2.4 2 times. Yeah, 2.4 2 times. Okay. So from here we are getting Kf value as 2 kilo. Now you can observe the units. It is very simple. Here left hand side you are having the frequency units are Hz, and right hand side you are having volts, right? That expression when you bring here denominator, so that means here you are getting Hz per volt. Okay, I hope it is clear for everyone how to write the order of the units. 2 kilohertz per volt. Okay. Now that is a case 1. Now read the question further. Now in case 1 you are having Am value 2.4 volt, but now what happened if the voltage is increased to 7.2? Okay, Am value modified. In case 2 Am value is 7.2 volts. Okay, just for reference here I am mentioning case 2. Okay, whatever we have discussed here, this is the case 1. Okay. Now when Am value modified from 2.4 to 7.2, now you have to find out regarding frequency deviation, 2 choices are there. Regarding modulation index you are having 2 choices. So among A and B you have to decide which one is correct. Among C and D you have to decide which one is correct. Okay. So once again formula will remain same. Delta F equal to Kf into Am. Delta F equal to Kf into Am. Just now we got Kf value as 2 kilohertz per volt. Okay, in simple I am mentioning only the value 2K. Okay, then into Am, that is 7.2. So 2 into 7.2, that is 14.4. 14.4 kilohertz. Here you are having hertz per volt, here volt. Both are getting cancelled, volts are getting cancelled. You are getting in the order of hertz. 14.4 kilohertz, that is there in option E. Option A. Now we have to calculate the modulation index. Modulation index formula you know, beta equal to delta F by Fm. Now delta F just now we got 14.4K divided by Fm. Fm they not modified, right? Whatever in case 1 you are having, same in case 2 also. 500 Hz. So just for easy understanding, this 500 Hz I am converting into, here since you are having kilo, right? So this one we can write it as 0.5 kilohertz, or in other words we can write it as 1/2 kilohertz. All are same only. Just to do the calculation simpler, whatever 500 Hz you are having, we can write it as 1/2 kilohertz, right? So here you can put 1/2 K. Now K is getting cancelled. This 2 will come into the numerator. Okay, so that means 2 into 14.4, that is nothing but 28.8. 28.8, that is there in option D. Okay, for this question, 2 choices are correct, option A and option D. Okay, I hope it is clear for everyone. If any of you are having any doubt, you can mention in the chat. Okay, next question, all of you give it, right? This question is also MSQ type. Nobita, you can cross check once for this question. All other students also please give a try. At least among 4 choices, if you observe 2 choices you are having regarding bandwidth, at least among those 2 you can identify which option is going to be correct. Similarly, other 2 choices you are having regarding power, regarding C and D you can identify. Okay, among A and B which option is going to be correct, among C and D which option is going to be correct. So in this question you are having the standard FM signal like AC cos 2 pi FCT plus beta sin 2 pi FMT. Okay, this is single tone modulation regarding FM. Okay, right. So just for reference, here I am writing the standard equation of FM signal. S of t equal to AC cos 2 pi FCT plus beta sine 2 pi FM into t. AC cos 2 pi FCT plus beta sine 2 pi FMT. This is the single tone modulation regarding FM signal standard equation. Now compare this equation with the given equation. From there you will be getting, first of all I am comparing regarding beta. So we are getting beta value as 3. So beta value 3, that is greater than 1, which indicates wideband FM. Wideband FM. So now wideband FM bandwidth formula you know, 2 into beta plus 1 into FM. So bandwidth equal to 2 into beta plus 1, that is 3 plus 1 into FM. Here FM value how much? 1000 pi t you are having, represent in 2 pi f format. 2 pi into 500 t, that means here you are having 500. Okay, I hope all of you got the clarity. Now 2 into 500 is nothing but 1000 or nothing but 1k. Okay, 3 plus 1 is nothing but 4, so you are getting 4 kilohertz. Okay, so that means bandwidth is going to be 4 kilohertz. Is it clear, Nobita? Even other students, please confirm. For this question regarding bandwidth, you are going to get 4 kilohertz. Okay. Now, other two choices you are having regarding power. See, the moment you have identified that the given signal is wideband FM, for wideband FM signal, what is the power? In order to transmit the wideband FM signal, what is the power? How much power we require? What is the formula? See, regarding narrowband FM, the formula you know, because I already mentioned earlier, narrowband FM signal regarding bandwidth is matching to the bandwidth of AM signal. Similarly, narrowband FM signal power formula will look like, or it will be similar to formula regarding AM signal power. Regarding AM signal power is what? PC into 1 plus mu square by 2. Like that, regarding narrowband FM signal power means PC into 1 plus beta square by 2. Okay, like that format you will be getting. Now here it is a wideband FM. In order to transmit the wideband FM signal, what is the power? I hope all of you learned regarding the Bessel function properties while doing the derivation of wideband FM signal. Okay. So you are, after doing a simplification, you will be getting power of the carrier signal before modulation, or you can say in other words unmodulated carrier signal power, all are one and the same. Power of wideband FM signal is nothing but carrier signal power. No, power is not same. Regarding wideband FM, narrowband FM, power is different. Because narrowband FM is looking like or similar to your AM signal, so that is the reason regarding power, regarding bandwidth, whatever you got for AM signal, similar formulas you are getting for narrowband FM. Yes, very good, Nobita. Here, like with respect to our entire communication system subject, R value you can consider 1 ohm. Okay, unless otherwise they are clearly mentioning for that question you can consider R value something. Okay, right. So here it is very simple. See, for easy understanding it is very simple. Suppose if you don't have this term, okay, how to remember? Okay, no issue. Like with respect to wideband FM, how to remember that the power of that particular signal is like this? Very simple. Whatever the term here you are having, if this term is not there, suppose, then you are having what? AC cos 2 pi FCT. For this power is what? AC square by 2. That's all. Okay. But regarding narrowband FM, why we are getting different formula? Because here beta value we have considered for less than 1. Then you are having like cos A plus B, cos A cos B minus sin A sin B. There we have done the approximation, like cos theta, cos 0 is nothing but 1. So like that we have considered cos theta value as 1, Sin theta we have considered approximately equal to theta. So since we have done like that expansion, from there we got the derived formula like that. But when you are having beta value very high, then definitely we cannot approximate. Okay, so that means this overall term you treat just like you are having AC cos 2 pi f t. After that, whatever you might be getting here, okay, then the power is nothing but AC square by 2. Exactly, it will match. That's all. Okay, of course, in your free time you can just go through the derivation regarding wideband FM signal, like by using Bessel function properties. We got the simplified equation as unmodulated carrier power. Okay, there we have considered the assumptions that for selected values of beta, like we have considered like at what values of beta the carrier signal power is 0. That means I mean to say after the modulation. Okay, but when you consider like you are having in that wideband FM signal, you are having infinite number of upper sideband, infinite number of lower sideband. Okay, when you consider all those signals and when you calculate the power with the help of Bessel function coefficient and like this cos terms, you will be getting cos 2 pi fc plus or minus nfm into t AC jn of beta, like that you will be getting coefficient wise. After doing the derivation, final expression you are getting AC square by 2. Okay, but exam point of view, just you can treat this entire function like AC cos 2 pi f t. That time you are getting PC. That's all. Now here you are having 50 whole square divided by 2. So 50 square is nothing but 2500 divided by 2, that is 1250. Units are watts. 1250 watts. So that is there in option D. For this question, two choices are correct, B and D. Yeah, next question, very interesting. All of you give it, right? Yeah, it is very simple. So first of all, read the question. here you are having the carrier and first upper sideband, carrier and first upper sideband. Those two frequencies difference, okay, they have given that is 2 kHz. 2 kHz in FM spectrum. Yes, very good, Nobita, very good. With respect to FM spectrum, like, so upper sideband, first upper sideband here it is mentioned, so that means FC plus FM, okay, this is the upper sideband frequency minus carrier frequency. The difference you are getting FM. In this question it is 2 kHz. FM equal to 2 kHz. Okay, right. Yes, very good, Ashni, very good. Now, whatever the FM signal here you are having, now that FM signal we have passed through frequency doubler. Frequency doubler means we are passing through a squaring circuit, you can say, or otherwise regarding frequency term it is becoming double. Okay, just for easy understanding, first I am writing generalized equation, like you are having FM signal like this, whatever the equation currently I have written here for single tone, AC cos 2 pi fct plus beta sin 2 pi fmt. Okay, this equation I am writing here. AC cos 2 pi fct plus beta sin 2 pi fm into t. Okay, this is the FM signal. This one we are passing through a frequency doubler. Okay, so for generalized case you can consider whatever here internal term you are having, the entire term you can consider like theta. Okay, you are having simple words AC cos theta you are having. Now that particular equation when you are passing through frequency multiplier, okay, the internal theta will become n times. Okay, in this question it is doubler, that means you have to multiply with 2. So AC cos 2 pi fct plus beta sin 2 pi fm into t, this overall term we have to multiply with 2. For generalized case, multiply with n. Okay, now you can represent further AC cos 2 into 2 pi fct. So that means here I am writing in the 2 pi f format, 2 pi into 2 fct, 2 pi into 2 fct, okay, plus 2 beta into sin 2 pi fm into t. So that means what is your observation? This is your FM signal, right? This FM signal when you are passing through frequency multiplier, where you are getting like this. Okay, so this equation is FM signal, this equation also FM signal only, but only the difference is in this equation the carrier signal frequency is FC, whereas here it is 2FC, but for generalized case NFC. Okay, similarly here you are having modulation index beta, for generalized case n times beta, but in this case frequency doubler 2 times beta. That means whenever you are passing a FM signal, whenever you are passing any FM signal through a frequency multiplier, the carrier frequency is going to change. Okay, the modulation index is going to change. Carrier frequency, modulation index are going to change, or in other words you can say carrier frequency and modulation index become n times. Okay, there is no change in the message signal frequency. There is no change in the message signal frequency. That means here with respect to this FM signal, the carrier, the difference of first upper sideband and carrier frequency difference is FM, right? Similarly with respect to this FM signal, you are getting the difference between first upper sideband and the carrier signal. Here in this case 2fc plus fm, this is your first upper sideband, okay, minus, here in this case the carrier frequency is 2fc, okay. So 2fc is getting cancelled, that means here also you are getting fm. Simple logic, simple logic. See, the separation or the frequency separation between first upper sideband and carrier frequency, or first carrier frequency and the like first lower sideband. So difference you are getting fm. So since in this process fm value not changed, fm value not changed, whatever original you are having, same answer, that's all, 2 kHz. Once if you know this basic point, this much derivation not at all required, because in this process, okay, whenever you are passing any FM signal through a frequency multiplier, only the carrier frequency and modulation index are going to change. Of course, if modulation index change, definitely delta F is going to change, okay, but FM value remains same, FM value will remain same. Once if you know that logic, definitely you can choose option C is the correct answer. But some students may do silly mistake here. Whatever the discussion here we have done, fc become n times, beta become n times, like that some students may do silly mistake. Here fm will become 2 times because we are passing through frequency doubler, 2 into 2k, that is 4k. That is also there in the given choices. In fact, that is there in the first option, okay. Whoever don't know the basic, definitely they may choose wrong answer as the correct one, okay. So that is the reason you should be fundamentally strong, and whatever the formulas you are having, you, like as I mentioned earlier, by practicing good number of questions, definitely each and every formula you are getting the familiarity, okay. Right, next question, all of you give a try. Yeah, this is a very good question, all of you give it. Yeah, for this question, in order to solve, you should remember one important point. For what values of beta, J naught of beta is going to be 0. At least you can remember starting 3 values or 4 values. If you remember, then you can solve this question. Okay. So just make a note for this question. J naught of beta is equal to 0. J naught of beta equal to 0 for beta equal to 2.4, 5.5, like that. Other numbers you can remember 8.6, 11.8. In this question, since the context is with respect to 2, accordingly I have represented. Okay, but continuation just for reference, if you want you can note down. Beta equal to 2.4, 5.5, 8.6, 11.8. Okay, now here see, when you are having J naught of beta equal to 0, that time the carrier signal amplitude will be 0. So definitely at the carrier frequency, when you represent on the spectrum, the corresponding signal strength will be 0. Okay, that is the meaning here. Okay, now read the question. You are having AM and FM, those are amplitude and frequency of the input signal given to a frequency modulator. FM they have given 5 kHz. Okay, AM value here we are varying. Okay, so the carrier component becomes vanished. The carrier component becomes vanished for first time when AM equal to 3 volt. When AM equal to 3 volt. Okay, so first let us consider that one. So here beta equal to KF AM by FM. See, the basic formula you are having delta F by FM, where delta F is nothing but KF into AM. Okay, now consider beta value 2.4 here. Then KF we don't know, let us calculate. Then here AM is 3, FM we are having 5 kHz. 5 kHz. Okay, right. Now here 3.8 times. Now do the cross multiplication. From here you are getting KFS 5 into 0.8, that is 4 kHz per volt. 4 kHz per volt. Okay, right. This is case 1. Now read the question further. The next value of AM, we have to find out when the carrier component vanishes for second time. Okay, second time is for this particular beta value. Okay, so once again same formula we can use. Here in this case beta value is 5.5 equal to KF, just now we got 4 kHz per volt. I am writing in short 4K. Okay, into AM we have to calculate, divide by FM value same, 5 kHz. Now here K is getting cancelled. AM equal to 5 into 5.5 divided by 4. Okay, do the simplification. From there you will be getting, all of you give a try, how much you are getting. Just do the simplification of this one and mention in the chart how much value you are getting. Ashwini, Nobita, you can do this simple calculation. If you want, you can use mobile or calci, your wish. You will be getting 6.875. Yes, very good, Nobita, very good. 6.875 volts. Okay, so here for solving this question, only if you can remember beta values, for what beta values here the carrier signal component become 0. If you know that one, then you can easily solve, because this formula you are familiar, beta equal to delta f by fm, that is nothing but kf into m. Only twist in this question, because like you should, if you know the beta values, for what values of beta, j naught of beta is going to be 0, then only we can solve this question. Okay. Right, next question, all of you give it, right? Yeah, Ashwini, actually this is not MSQ. Actually, you have to read the question. Actually, here in this question, now I have put the twist. What is the twist? Here I asked that choose the incorrect statement. Choose the incorrect statement. Suppose if the same question, if I ask that choose the correct statement or statements, then whatever the options you mentioned, that is true. Okay. In this question, I put here twist, incorrect statement. Okay. Yeah, very good, Novita. Very good. See here, power required for transmitting wideband FM, we already discussed. Power required for transmitting wideband FM. So that is same as unmodulated carrier signal power, right? In short, it is a PC. Yes, that is true only. This statement is true only. Okay, that means that is not correct. Okay, that is not the correct answer for this question, because according to the context of the question, we have to answer accordingly. Okay. Right. Next, wideband FM requires less power when compared to AM signal. Okay. So regarding AM signal, the power we already discussed, PC into 1 plus mu square by 2. 1 plus mu square by 2. Okay. Here with respect to AM signal, we are using modulation index value less than or equal to 1. Okay. So here just observe, whatever the modulation index you are considering less than or equal to 1, but that value after you are substituting, definitely that overall value when after whatever the value you are getting, after you are substituting, this overall value you are getting greater than 1. Okay. So when you are multiplying greater than 1 with PC, definitely it is greater than PC only. That means here what we can give the conclusion, power of wideband FM signal, is less than that of power of AM signal, or in other words, the power required for transmitting AM signal is more when compared to power required for transmitting wideband FM. So that means wideband FM requires less power when compared to AM signal. Statement wise it is correct. Okay. Next, the power of wideband FM signal is independent of modulation index. Yes, that is also correct statement, because here AM signal power depends on the modulation index, whereas wideband FM, see here in the wideband FM regarding the power, after doing the simplification, you are getting unmodulated carrier signal power. Okay. So in this equation, since beta is not there, so that is the reason here it is independent. Okay. Whereas in the option D, the power of wideband signal dependent. So that is not the correct statement, hence it is the correct answer for this question. So in the GATE exam, not only in this subject, in any subject, okay, especially for MCQ question or MSQ question, right, before you are choosing the options, okay, once again, whatever the answer you feel that you want to choose for that question, once again read the context of the question. see in some questions, just like this question, in every question, or I can say in most of the questions, whatever the main keyword is given, so according to that context, just like earlier also I have mentioned for NIT questions, especially like for whichever parameters you're having, order of units, like in the order of kilohertz or in the order of hertz or in the order of microvolt or millivolt, etc. Okay, so those questions you can take care about the order of units. For these kind of questions, you take care about the main keyword. So according to the context, we have to answer. Even though you are good at like solving the question and you understood very well, but only thing, according to the context of the question, if you are not answering, okay, for MCQ question, definitely there will be native marking. Of course, for MSQ, there is no native marking, there is no partial marking. But for MSQ question, if you want to get the marks assigned for that question, whichever correct options are there, you have to choose. Okay. So in the GATE exam, my suggestion is regarding MSQ question. Like after seeing the question, if you feel that you can solve in less time, definitely do it at that time. But whichever MSQ questions, after reading the question, if you feel that, sir, it may take more time, then definitely you can hold those MSQ questions in the initial 1.5 hours. Okay, don't attempt those questions. Better you can solve those questions in the second 1.5 hour time, whenever you are having some extra, some leftover time, if it is there, that time you can solve. Because for MCQ question, the moment you are getting like either correct option, you can choose, because only one correct option is there. Or suppose some questions, sometimes you cannot choose the correct option directly. In such cases, at least you can eliminate the wrong choices. In that manner, if you are able to eliminate 3 wrong choices, from there leftover option is correct one. In that manner, while you are solving MCQ, you are solving the given question only one time. But for MSQ, either you might be solving 2 times, or either you might be solving 3 times or 4 times, based on the given choices. Okay, if they have given different parameter in each choice, that means even though looking wise one question, but solving wise you are solving 4 questions. Ultimately, at max you can get either 1 mark or 2 mark, right? That is the reason you can do the strategy like whichever questions are easy, whether it can be MCQ or MSQ, NIT, irrespective of type of question. If you feel after reading the question, if you can solve immediately or in less time, do it. Whichever questions are taking more time, you can hold in the first round, you can do in the second round or third round, like that. Okay, in that way if you follow, definitely you can maximize your score. Okay, and whatever the like whoever the students are doing the silly mistake, don't hesitate or don't worry. Okay, but whatever the silly mistakes either you might be doing or other students might be doing, at least you can keep a note of all these things. Definitely all these from all the mistakes, whatever the learnings are there, definitely with the help of these learnings, you see, our main objective is in the actual GATE exam, we should not do any silly mistake, or I can say at least even if you are doing silly mistake, but you can minimize, try to minimize as much as possible. Okay, so that you like whatever the marks you are supposed to get, definitely you can maximize your score. Okay, right. Next question, all of you give it, right? Up to previous question we have discussed regarding first chapter and second chapter. In this question, in order to solve this question, you can consider this question belongs to third chapter, and even in order to solve that question we are using the concept of the second chapter as well. So that means this question you can consider the combination of both second chapter and third chapter. First of all, read the given data and from there note down the important information, and from there you will be getting a clue how to solve this question. So you are having one baseband signal, okay, 15 kilohertz bandwidth. So now you can tell me, definitely you will tell this is what your FM, that's all. You are having baseband signal. Whenever baseband signal, modulating signal, message signal all are one and the same, you are having low frequency signal. So low frequency signal, maximum frequency and bandwidth of that particular signal both are same. Okay, that is 15 kilohertz. Yes, very good Nobita, very good. So here you are having FM equal to 15 kilohertz, right? Okay. Now the number of channels available. This is the question. Okay, number of channels available in the frequency band. In the frequency band 500 kilohertz to 5 megahertz. So that means this is the channel bandwidth. Okay, in this channel how many FM signals are of this type? Okay, with respect to this FM signal, and here you are having maximum frequency deviation 75 kilohertz. Okay, that is the question. Okay, so first let us consider, okay, frequency deviation delta F equal to 75 kilohertz. Now you can calculate the beta. Beta equal to delta F by FM, 75k divided by 15k. So from here you are getting 5, which is greater than 1, which indicates wideband FM. So in any question, if they don't specify whether the given FM signal is wideband or narrow band, so from the given data delta F and FM, after using this particular standard formula regarding modulation index, from there you will come to know whether it is narrow band or wideband. Okay, now it is wideband, so you can use wideband FM signal with respect to that bandwidth, that's all. So bandwidth of wideband FM signal, bandwidth of wideband FM signal 2 into beta plus 1 into FM. Here beta value is 5 plus 1 into FM. FM is 15k. Right. So here 5 plus 1 is 6. Okay. Then 2 15s are 30. 30 into 6, 180. Right. 180 kilohertz. See, if you are transmitting only this particular signal, then in the channel we require 180 kilohertz bandwidth. Okay, but in this particular channel you are having this much range frequency band. Okay, so when you are performing subtraction of lower frequency from highest, from there you are getting channel bandwidth. Okay, in that channel bandwidth, like these signals, how many we can transmit, that's all. Yeah, first of all you can calculate the channel bandwidth. Here 5 megahertz you are having, here 500 kilo you are having. Okay, let us convert this one in the order of kilohertz. 5 mega we can write it as 5000 kilo. Yes or no? 1000 is nothing but 10 power 3, kilo is nothing but 10 power 3, you are getting 10 power 6, that is nothing but mega. Okay, then here you are having 500k. So 5000k minus 500k, that means 4500 kilohertz. Okay, this much channel bandwidth you are having. In that channel bandwidth, with the help of this much channel bandwidth, like this FM signals, how many we can transmit, that's all. Yeah, Ashni, you can give a try now. Okay, we have solved almost regarding this solution. Okay, after, with the help of this much information, at least you can give a try. Yeah, here we have to find out number of channels. Number of channels available for FM signals. Is equal to, yes, very good Ashni, very good. It is very simple. The total channel bandwidth, how much available, that you can consider 4500 kilo divided by here 180k, that's all. So here kilo is getting cancelled, then 920s are 80, otherwise you can cancel 1 0. Yeah, you can cancel this 0, then 9 2s are 18, then 950s are 450, 225 times. So that means you can have FM broadcasting stations 25. Okay, for every station we are like 180 kilohertz. Okay, 180 kilohertz bandwidth we are allocating for every station. So like that you can transmit like 25 stations, from 25 different stations we can transmit like this signals in the given channel bandwidth. Okay, or in other words, suppose if you are having one broadcasting station, example, like for one broadcasting station, suppose if we have allocated this much bandwidth. Okay, so for one signal, since we require this much bandwidth, with the help of that one broadcasting station, we can transmit or we can have like 25 channels. Okay, like that, in any manner you can consider. Okay, next question, all of you give a try. This may take time because in order to solve the question, like calculation wise, may take more time. Okay, I will be giving more time for this question, all of you give a try. Yes, very good, Novita, Akanksha. Yeah. So out of 4 choices, you have mentioned 2 choices. Okay, those 2 are correct. Actually, in fact, for this question, other 2 choices also will be correct. Okay. Yeah, first of all, read the question. You are having regarding superheterodyne receiver is tuned to 555 kHz. That means you are selecting like regarding the incoming signal station frequency is 555. So Fs equal to 555 kHz. Okay, Fs equal to 555 kHz. Okay, Nobita. Okay, we'll discuss. Okay, regarding the formula, I will be discussing. After that, once again, you can substitute. Okay, whether it is matching or not, we'll see. Right. Here, incoming signal is 555 kHz. Now, the local oscillator frequency is adjusted to 1010 kHz. That means here local oscillator frequency is 1010 kHz. Okay. Now in this question they have given Q value as 40. Okay, that we'll use later. Now they are asking regarding intermediate frequency and then image signal frequency. See, in any question, if they don't specify whether the local oscillator frequency is greater when compared to the incoming signal or not, if they don't specify, by default you can consider the local oscillator frequency only greater when compared to incoming signal. Of course, in this question, since already you are having the frequencies, here you are getting the relation as FL is greater than Fs. FL is greater than Fs. Okay, but in some questions, if they don't give the relation between FL and Fs, by default you can consider like this. Unless otherwise they mention other way. Okay, right. So in this question, since you are having Fs is less when compared to FL, or other words, FL is greater when compared to Fs. That means definitely image frequency. With this understanding, tell me, like when you are having the frequency axis, okay, so 555 kHz station you are having here. Okay, now image station, whether you will be getting right hand side or whether you will be getting left hand side, all of you just tell me for this particular relation. For this question, I am repeating once again, when you are having frequency axis like this, okay, 555 kHz station you are having here. Now image frequency you will be getting right hand side or left hand side for this question. This is a very, very interesting thing. Yeah, meanwhile, see here we are using what? One mixer. Okay. Yeah, no, Vita, it is not correct. Okay, you will be getting clarity. So here what happened, like incoming signal station is 555 kHz and here local oscillator frequency we have given 1010 kHz. Okay, these two signals we are giving as what? Input for mixer. Okay, mixer will produce either addition of two frequency or subtraction, but here our objective is subtraction. Okay, accordingly we will pass that particular frequency. Okay, so whenever you are performing subtraction, always will perform subtract smaller from larger, because frequency can never be negative, right? So that means here intermediate frequency you are getting FL minus Fs. In this case FL is larger when compared to Fs. Okay, FL minus Fs. So here 1010 kHz minus 555 kilo. 555K. Okay, from here you will be getting 455 kHz. Yes, that is there in option A. Intermediate frequency 455 kHz. Okay, now image signal frequency. See, when you are having the relation like this, this time image frequency you will be getting on the right hand side. Okay, you will be getting on the right hand side. So that time the formula is Fs plus 2 times intermediate frequency. Fs plus 2 times intermediate frequency. Okay, so here Fs is 555K plus 2 times intermediate frequency, that is 455K. Okay, do the simplification. Here the first one 555K, then here you will be getting 910K. Okay, after that you can do simplification. You will be getting 1465 kHz. 1465 kHz. Yeah, just observe here. See, when you have selected, okay, as of now we got 1465 kHz. So accordingly we can select this image signal frequency. Option B is correct, 1465. Now just observe here. Actually, here in order to select this particular station, what we have done, with the help of local oscillator, we have adjusted to one frequency. That time, since this frequency is larger when compared to this one, difference of those two, that is the intermediate frequency 455 kHz, right? Okay. Now, when you have kept local oscillator frequency 1010 kHz, okay. Now, with respect to this signal, you are getting one more signal. Say for example, this is station 1, this is one more station, okay. So now, when you observe here, see at the receiver, you are having one antenna. Suppose when you are broadcasting from different stations and all, definitely that particular antenna can receive any of the signals, whichever are incoming, right? Suppose with respect to this signal, when we have kept local oscillator frequency here like this, accordingly we are getting intermediate frequency like this. Okay. Now, whatever the intermediate frequency you got, 455 kHz, that particular signal we are amplifying, okay, with the help of IF amplifier. After that, the process will continue. Now, in this case, what happened? When you are having one of the incoming signal station, frequency is 1465 kHz. Now, in this case, for the mixer, you are having two incoming signals. One is incoming signal, another one local oscillator. In this case, what happened? Your incoming signal frequency is more when compared to local oscillator. Here you can perform subtraction. Okay, so you are subtracting this one from here. 1465K minus 1010K, what you are getting difference? All of you just cross check. 1465K minus 1010K. So you are getting what? 455 kHz. So that means the same intermediate frequency, right? So actually our objective is we want to select this particular station, but when we have kept local oscillator frequency like this, even when you are getting one more station frequency like this, even for this particular station frequency, you are getting the same intermediate frequency. So that means with respect to this signal, that signal is what? Interference or image frequency, image signal you can say. So that is the reason with respect to 555 kHz, 1465 kHz you are getting on the right hand side. Okay, this is one logic. Whenever you are having the relation like this. In this case, FL is greater when compared to FS. Okay, when you are getting like this, image frequency you are getting right hand side. Suppose in another case, if this is your desired incoming station, if you want to select this particular station, then image frequency will come this side, like that, vice versa. Okay, I hope it is clear for everyone. How to see the incoming signal and local oscillator frequency relation. Okay, in majority of the cases, they will be asking the question with respect like this. Whenever in the question, if they don't specify regarding this particular relation, by default you can consider like this. But whenever in some questions, if they want to put twist, they can mention that incoming signal frequency is greater when compared to local oscillator. That time image frequency you are getting left hand side. Okay, right. So as of now, option A, option B are correct. Now coming to the row. Okay, so just one second. Yeah, rho equal to FSI divided by FS minus Fs divided by FSI. See, it is very simple. Here you are taking ratio of two frequencies. which term should come which side? It is very simple. When you observe here, FS and FSI, which one is larger? FSI. So that means when you are taking ratio of two numbers like this, okay, FSI is larger when compared to FS, definitely you are getting here greater, like you can say like positive number, okay. Since denominator value is less when compared to numerator, definitely overall number will be larger, okay. So here you are making exactly opposite, that means this one is smaller, this one is larger, obviously overall value you are getting positive, like that you can remember, okay. Right. Now 1465K divided by 555K minus 555K divided by 1465K. Now all of you cross check once again after doing the simplification, what is the value you are getting? All of you do it. Akansha, Ashni, Nobita, everyone can do once again. Just do the simplification of this one. How much you are getting, you can mention in the chart. You can use mobile or calci. I hope all of you will get 2.91. All of you confirm once. Okay, see, it is very simple. Just at least you can do approximation. Okay, for the time being, of course, you no need to do like this approximation in the exam, but at least here when you're having the choices, like suppose like for the same question, suppose only for calculation of row and the question is MCQ, that time at least you can do approximation calculation wise. Say for example here 1465 is there, approximate to 1500 example. Here 555 is there, approximate to 500 example. Okay, so here 1500 by 500, that means you are getting 3. If you are getting this is 3, this will be 1 by 3. So that means 1 by 3 is nothing but what? 0.3 something. So 3 minus 0.3, so that means 2.7. Okay, but here, so at least you are coming to know one guess that this overall value will be less than 3. Like that you are getting based on the approximation you can see. Say for example, whatever the choices you are having regarding row value, I mean to say, suppose only one choice you are having between 2 to 3, remaining choices you are having like greater than 3 or less than 2, etc. At least in that case, you, by this approximation method, you can easily figure out which option could be the correct. Okay, right. So 2.91 we are getting, yes, that means option C is correct. Now coming to the image rejection ratio, IRR, the formula is image rejection ratio IRR is equal to square root of 1 plus q square rho square. This is the formula. Image rejection ratio equal to root 1 plus q square rho square. So here in this question, quality factor given as 40 whole square then rho value just now we got 2.91 whole square. Okay, now all of you do the simplification, and now you can verify how much you are getting. You will be getting 116.4. See, here also you can verify by approximation method, like when compared to this overall number, this 1 we can neglect, right? Okay, now when you neglect this 1, root and then square, both are getting cancelled. 40 into the suppose 2.9 you can consider like 3. 3 40s are 120. That means here value will be less than 120 but nearer to 120. Like that you can verify. Is it clear, Nobita? So for this question, all the 4 choices are correct. For this question, all the 4 choices are correct. Nobita, if you are having any doubt, you can mention the chart. Okay, I hope it is clear for everyone. For the timing, I am showing the next question. If any of you are having doubt in the previous question, you can mention the chart. So this question is MSQ. Choose the correct option or options. This question is MSQ. Yeah, if you read the question, whatever the context we have discussed in the previous question, exactly same. You can observe here, local oscillator frequency FL is greater than FS. That means image frequency will be on the right hand side. Okay, so since you are having FL greater than FS, image frequency FSI equal to FS plus 2 times intermediate frequency. 2 times intermediate frequency. Okay. So, yeah, here in this question, you are having image signal frequency 2110 kilo, 2110 kilohertz. Okay, Fs we have to calculate in this question plus 2 times intermediate frequency. Here intermediate frequency is 455 kilohertz. 455 kilohertz. Okay, so from here you will be getting Fs equal to 2110k minus, here you will be getting 910 kilohertz. 910 kilohertz, right? So from here you will be getting 21 minus 9, that is 12. 1200 kilohertz you are getting. So Fs you are having 1200 kilohertz. Fs you are having 1200 kilohertz, right? So that means option B is the correct one. Among A and B, B is the correct one. Now we have to find out regarding FL. See, we already mentioned here FL greater than Fs. Intermediate frequency means difference of the incoming signal frequency, that's all. Okay, here FL is greater when compared to Fs. So that means here intermediate frequency will be equal to FL minus Fs. Okay, FL we have to calculate in this question. FL we have to calculate. Intermediate frequency is 455K. Fs just now we got 1200K. Now from here FL you are getting 1200K plus 455. So that means 1200K plus 455K. So you will be getting 1655 kilohertz. Okay, 1655 kilohertz, that is there in option D. So for this question, two choices are correct. Option B and option D. See, no need to have any confusion. Just like the previous question, this question also. Condition is same. FL greater than Fs. Okay. Here in the previous question, Fs is given. Okay, we have calculated the image frequency. But in this question, image frequency given, intermediate frequency given, Fs we calculated, and after that we calculated the local oscillator frequency. In this way, whatever the models we are discussing regarding MSQ, at least you are getting a clarity regarding communication system subject in which manner you can get regarding MSQ question. Okay, whenever for solving the given question, if two parameters are there, they can give two choices regarding one parameter, two choices regarding other parameter. But if you are having four parameters regarding that concept, they can give in extreme case one option with respect to one parameter. Okay, now the last question regarding this particular session, all of you give it a try. I hope all of you can get the correct answers for this question. This question is also MSQ. Either one option or more than one option can be correct. All of you give it a try. See, this is the question based on FDM, frequency division multiplexing. So here we are having total 10 signals, each band limited to 5 kHz. Band limited means the maximum frequency they have given. Starting frequency will be 0, maximum frequency is 5K. That means for here 10 signals you are having, for every signal the maximum frequency is 5K. That means FM is 5K. Yeah, very good, Ashni. You can cross check one more option also. Okay, as of now you have mentioned 2 options, those 2 are correct. You can just cross check one more option also. Okay, one more option also is going to be correct for this question. And these 10 signals are transmitted through a channel simultaneously using FDM, and here in this question God band is provided 2 kHz. So God band means very simple, in order to separate the previous signal with the current signal, okay, whatever the range of frequencies we are allocated, that in that range of frequency we don't have any main signal component, but just in order to separate the previous station with the current station or previous signal with the current signal. Okay, so here in this question God band they have mentioned 2 kHz, and this God band we have to consider, say for example if you are having total number of signals are n, we have to consider God band n minus 1, that's all. We no need to bother before first signal, we no need to bother after the last signal. Okay, between like first signal, second signal, second and third, third and fourth, like that we have to consider, that's all. Okay, yes, very good Ashni, very good, excellent. Now here in option A, option B, if you observe whatever the modulators, okay, we have used, those are AM, okay, whereas in option B we have used DSBSC, whereas in option D SSBSC. I hope all of you know regarding AM signal and DSBSC signal, bandwidth of the modulated signal is same, that is 2 FM, right. So with respect to AM or with respect to DSBSC, when you are having only one signal, bandwidth is 2 FM, bandwidth is 2 FM, okay, but in this question you are having 10 signals, okay, so you can multiply with 10, this much. When in the question if they specify that if there is no God band allowed, then this much bandwidth required, but in this question they mentioned God band is also allowed. Since you are having 10 signals, 10 minus 1 we have to consider into how much God band here we allocated, that much you can consider, that's all. Okay, so here 10 into 2, that is 20 FM plus 9 into 2K. Here in this case FM is 5K, so 20 into 5K plus 9 2s are 18K, 25s are 100, 100K plus 18K, that is 118. 118 kHz, that is there in both option B, option C. Option A, option B you are having AM, option B you are having DSBSC. Okay, for both the cases 118 kHz. See, option A, in which case it can be correct if there is no God band. If there is no God band, that time you require 100 kHz. In that case we can choose option A. Okay, now coming to the option D. Now coming to the option D, here we are having SSBSC. So with respect to SSBSC, the bandwidth is FM only. With respect to one signal I am talking. With respect to one signal, FM. Okay. So now currently 10 signals are there, 10 into FM plus this entire, whatever here we got, exactly same. 10 minus 1 into 2K. Regarding God band, as it is. Okay. So here 10 into FM is 5K plus this one, after doing the simplification we got 18K. So 50 plus 18, that is 68. 68 kHz, yes, option D is also correct. In this way, whenever you are having MSQ, okay, if the question is simple, you can solve at the same time. If the question is time taking, you can hold those questions in the first round, you can do in the second round or third round in the GATE exam. Okay, so in this particular session, we have discussed total 20 questions. Total we have discussed 20 questions. Okay, so these 20 questions regarding the first 3 chapters of communication system subject. So introduction, amplitude modulation, and then angle modulation, and then AM and FM receivers. Okay. Similarly, in tomorrow's session, we will be discussing the questions related to the remaining chapters, remaining 4 chapters, that is random process and noise. After that, regarding digital communication, we are having 2 chapters, baseband data transmission and then band pass data transmission, and the last chapter is information theory. Okay. So regarding those 4 chapters, related important questions or important concepts related questions, I will be covering in tomorrow's session. Okay. So all of you can share your valuable experience, whatever you people got from this particular session. You people can share your experience in the chat, whoever attending in the live, and whoever watching this session in the recorded manner, those students can mention in the comment section as well. Okay. So I am very happy to see all of your presence in this particular live session. Okay. I hope all of you got maximum benefit from this particular session, and in whichever areas, okay, even though like you might be very much strong in most of the concepts, but in few areas where you are having little bit confusion, or you people are doing some silly mistakes, few students, at least you are coming to know, you are getting one alert with the help of this session. Definitely you people can overcome these silly mistakes in the upcoming GATE exam. Okay, right. So as I mentioned earlier, today after this session getting over, today I will mention in the comment section, like some students have requested that, sir, regarding this particular subject, the important points and formulas regarding this particular subject, so they requested. So regarding that one, I have done in one of the earlier year in our YouTube channel. Regarding that particular link, I will be putting in the comment section today itself. And some students have requested that, sir, they want some more extra questions, practice questions. Okay, so for them, I will be putting tomorrow. Okay, tomorrow after the second session got over, at the end of tomorrow, okay, in that second session link, I will be putting like this. This year we are doing GATE score booster, right, for GATE 2025 exam, right. Similarly, for one of the earlier year, I have done GATE score booster regarding communication system subject. So those session links I will be putting in the comment section, and in addition to that, I will be putting one more playlist link also regarding GATE PYQs. Okay, some of the very good models regarding GATE PYQs of communication system subject, that also I am having one playlist. Okay, that playlist link also I will be putting on tomorrow. Okay, because before practicing those questions, whatever we are discussing like today and tomorrow, all together these questions are more than sufficient. But whoever having some extra time and whoever want to get some more better, whoever want to perform like very well in the communication system subject, for them, based on how much time, extra time you can devote, for them I am giving some extra links. Definitely whoever going through these links and whoever practicing the questions from these YouTube links, definitely all those students can maximize your marks in the communication system subject. Okay, right. So with this I am concluding in today's session. So all of you, like whoever not yet joined our Telegram channel, regarding the link already provided in the description of this particular video, so all of you can kindly join. It is free for everyone, and all of you can share this valuable information to all of your friends and juniors. Okay, so here whenever we are conducting the live sessions, okay, regarding that particular updates you will be getting in our Telegram channel, and whatever we have written during our live class, that particular lecture notes we are sharing in the PDF form in this particular group, and all these important updates you are getting in our Telegram channel. Okay, and as I mentioned earlier, whoever like writing GATE 25 exam and whoever not enrolled at our IMS GATE Academy for any of the program, for all those students I am strongly recommending to enroll for our Test Series Plus program, because whatever the kind of quality questions you people are getting with the help of our GATE score booster series, definitely like that questions you should solve good number of questions before your GATE exam, so that you can get you can get the confidence and you can overcome the silly mistakes, and you can get regarding the time management all the tips and techniques with the help of our quality test series. Okay, and along with that we are providing 33 years GATE PYQ booklet regarding your technical part, and along with that maths and GA we are providing all the 6 branches as well. Okay, and all these benefits you are getting. So for all those students I am recommending you people can enroll for Test Series Plus program. As of now the limited time period offer is running 20% offer. Okay, and whoever currently studying BTech second year or third year and whoever want to write the GATE exam in the upcoming years, for them I am recommending you people can enroll for the live online program. So all these are our regarding the features regarding live online program. Whoever interested, those students can book the free counseling session regarding the link also provided in the description of this particular video. Our counselors will discuss in detail about our live online program. Okay, so that's all in today's session. We'll meet you all on tomorrow. Okay, once again thank you everyone whoever attended during the live session and even whoever going to watch this particular session later in the recorded form. Okay, we'll meet you all on tomorrow. Most probably the session is going to start at 4 o'clock tomorrow. Okay, so we'll meet you all in that session. Thank you everyone.